All right, welcome to class. With us this morning, we want to discuss velocity time graph. Now, what is velocity time graph? Velocity time graph can be defined as the graph that shows the relationship between one, acceleration, two, constant or uniform speed, speed, three, deceleration. Now, the graph that shows all the relationship between these. Now, this is measured in meter per second square. This is measured in meter per second. And then this is measured in meter per second square, 2. Now, how do we now introduce the graph? From here, we said that the graph is, you are plotting velocity against time. That's the graph. Plotting velocity against time. Plotting velocity against time. So this is the time. The time is measured in seconds. This is the velocity, is measured in meter per second squared. Now, just a rough sketch. Whenever they say a body accelerates, acceleration is this one. Any movement from the point of origin or from rest is this movement is describing acceleration. That's what this movement is describing. Next up, whenever you hear constant or uniform speed, it maintains a constant or uniform speed. It goes like this. This is speed. It goes like this. Next, whenever you hear deceleration, that means it comes back to rest. It comes back to rest. That's the concept. It comes back to rest. So this is the concept. This is it. So here is constant or uniform speed. Constant or uniform speed. Why this is deceleration. So this is just all about the graph. Also, what do you also need to note? Note that the speed is the relationship between the constant or uniform speed. That is it. The relationship between the constant and the time. That means I'm talking about the time now. For you to calculate the time, the diagram will always, there is always a line that will come from the constant speed to the time, from the constant speed to the time. Now, this is the concept. Also note that this is a diagram. This is a diagram. So we're using the area. We're using area to calculate the diagrams. This is also a diagram, and this is also a diagram. So all of these are diagram put together. So you can label them as 1, 2, and 3, or A, B, and C, as the case is. Now, also note that if the acceleration from here to here is measured to be, let's say, 5 seconds, and then when it's now maintain constant speed or uniform speed down to this place with a time of 10, let's say 10. Now, this is what you do. You will not write the 10. You're not writing the 10. It maintains the speed from here to here. You're not writing the 10. You're going to add it. You're adding it from here. You're adding this 5 to that 10. So here becomes 15. That's the concept. You keep adding up the time. That is how the concept is. So you keep adding the time. Now this place is the velocity. Then let's say this body accelerated at the velocity of, let's say, 30. So every velocity is here. Now you don't add up this velocity. This velocity is not added. You don't add it. You just write the velocity that is given or mentioned in the question. So this is how everything about this is done. So whenever you ask to calculate the total movement of the vehicle from the point of rest down to this point, you are simply asked to add up all the areas, the areas of the diagram, the area of the diagram, the area of the, add it up, and then you get your final single answer. So this is how it works. So let's deal with some questions. All right. So we want to do question number 1. For question number 1, we are told that a car starts from rest and accelerates. So whenever you hear the word accelerate or acceleration, whenever you hear the word accelerate or acceleration, it has a concept that is this one going up. So let me have the diagram here. Let me do it like this, and let me take this one like this. So let's just take this one. So this is my velocity and this is my time. So we are doing V against T, which is in seconds. Okay, let's do this one. Now, a body accelerates. The word accelerate goes up like this. That's all. They said uniformly until it reaches the velocity of 30. So this place goes like this now. This is the velocity sign. So we have 30 meter per second. Yeah. They now said after 5 seconds. So the first time has been given. So the first time here is 5 seconds. Full stop. They say it maintain. Whenever you hear maintain the velocity, same as your constant speed. And I told you that it goes like this. That's how it goes. That's the direction. And reaches for 15 seconds. So I said this 15 seconds, I'm not going to write it 15 seconds like this, but adding it to this. So because time is added. Time is added. So 15 plus this 5. That will give us what? 20. So this is what I'm having here. Now from this point, what is next? See, it brought to rest in 10 seconds. So I'm adding 10 to this one. Next one, not this one again, the next one is brought to rest. So it's coming down. That's what it means. For 10 seconds. So you're adding 10 to this one. That will give us 30. So this is my diagram. Now, from this point, what is the next thing we'll do? Then I'll say with a uniform retardation. So please note that the word retardation is the same thing as the word deceleration. It's the same thing as the word deceleration. And retardation is the opposite of acceleration. Likewise, deceleration is also the opposite of acceleration. So this is the concept. So that means this part is my deceleration. This part is my constant or uniform speed. And this part is my acceleration all together. So this is the concept of how these things are done. So let's go ahead. Let's start solving questions here. So I will take this one off. I'll take these questions off so that I can have a place to solve. So now, what is the next thing for us to do in the question? So first, we want to calculate A. So for us to calculate A is simply the acceleration of the car. So this is where we want to calculate the acceleration of the car. So how do we then calculate A? Acceleration of the car. Simple. You apply the formula. You go back to equation of motion. You have equation of motion formula, which is V is equals to U plus AT. So we want to calculate A. So we say recall that this is equals to U plus AT. So they said acceleration. So let's make this one simple the formula. First, I'll take this one here. So if I do that, I'm having this equals to AT. So I'm looking for A. So I will divide here by T, divide here by T, so that this can take care of this. A therefore becomes V minus U over T, because I'm looking for acceleration here. So now, note that at this point of origin, that is this point of rest here is 0 before it now accelerates upward. So here is my U. This part where the car was before it started accelerating. This is my U. As I accelerate here, they said with a velocity of 30, this is my V. And then with this time. So what then do we now do now? We are looking for A. So we just impute values. So where we say A becomes, what is my V here? Just trace it here. This is the velocity. Trace it here. Is then 30 minus, what is my U? My U is 0 because the car was at rest before the acceleration takes place. And what is my T? At this time, 5. So A becomes 30 minus this. So A becomes 6 meter per second square. So this is how this is calculated. This is it. This is the first of the question on the board here. This is it. Now, next question we want to do is B, the retardation. The retardation. So I'll take this off. Retardation. So how do we calculate the retardation? So B, want to calculate the retardation of the car. That means when it decelerated, that is what we mean, retardation. So from this point now, what does it mean? Is this point where this comes down. Now, before it comes down here, the car went here and then comes down here. So in physics, here, where the car rested here before coming down is my U now. Then coming down becomes, this point here becomes my V, where the car will now rest. So what does that mean? We are still applying the same formula. Remember I said retardation is the opposite of acceleration. So they are sharing the same formula. So where we say the same formula I just used now, where we say A becomes V minus U over T. So opposite of this, that's what we want to calculate now. Now, what do we now know? From here now, my U is now this one. This is my U now. This becomes my U. While V dropping down to rest becomes my 0. So I have that my V now is 0 because when it drops, when it decelerates, that means to rest, it means it's 0. That's what they are saying there. So that's 0. So minus the new, just trace this one here, trace it here. This U becomes the acceleration now. So here becomes 30 all over the time. What is the time here? We have 30 and 20, so subtract. You must subtract for the time. That becomes 30 minus 20. You must subtract. You must subtract the time here. So we'll now have, remember this one, we only have one time here where we did what? 0 and 5 there. That's what we did to get time. So please watch that. So here becomes minus 30 and then 10 here. So if you do the math, this cancels this. A therefore becomes minus 3 meter per second square. So this is the reason why it's called the opposite or the negative of acceleration. This is it. So B has been calculated as our retardation. Please note that you don't use 2 times. Please, you reduce it to 1. So that becomes the big minus the small one. 30 minus 20, that gives you 10. So that is what we used here. So that's what I'm showing you here. So this is it. This is how we calculate B. So next up, I want to calculate C, the distance covered in 5 seconds. The distance covered in 5 seconds. So I want to calculate C now. The distance covered in 5 seconds. The distance covered in 5 seconds. So C, want to calculate the distance that was covered. The distance covered in 5 seconds. So this is the second. So that means this is what we want to calculate. So all of this one, this is the seconds here. The first diagram, that's what we want to calculate. So the first diagram is like this. So this is the first diagram. So here, all of these points is my 5. And then all of this one, look at this diagram. You know, this diagram here like this is also what we have here. This is the inverted part. Look at it. This one has been inverted. So all of this part is my 30, which is same as this one. This line to this line is the same as 30. So this line is like the same thing. So I will have 30 here. So the distance covered is simply using the area of this, which is half base times height. That's the distance covered for this diagram here. So that becomes half here times, what is my base? My base is 5 times the height. This is the height. Either here or here is the height. So here becomes 30. So I can cancel this one to give me 15. So the area therefore becomes 15 times 5. That will give me 75 meter per second and 75 meter square. Area is meter square. So this is it. This is how it is calculated. That's the C question. The distance covered in the first 5 seconds. So this is how it is done. Now, D, you want to calculate the total distance covered. The total distance covered, D. D, the total distance covered, D. So what is the meaning of that? I already told you that the meaning of that is that we are calculating all of the diagram. All of the diagram, total distance covered. So we are adding up all of the diagram. That means this diagram first. So I'm taking the first diagram out. You don't need to put the diagram like this. I'm just the one doing these settings. You don't need to put the diagram like this. So plus this rectangle out, I'm just bringing them out. Then plus this one also out. So you are summing them up. So from here, I already know this one. I know this one because we have solved this one. This one is 75, but let's do that. So we are calculating all of them. So let's do that. So this becomes half times this for this one, plus this one is length times breadth, plus this is the same diagram here. So this becomes half base times height. So from this point, what do I do from here? I already know this one. That's the first diagram. You can label it as 1, 2, 3, or A, B, and C. Anyone you like, you are correct. Anyone you like, you are correct. So let me label it 1, 2, 3. So this is my 1, this is my 2, and this is my 3. So for the 1 now, we already know this to become my base is this one here. This is the base, which is 5. My height is this 30, which is this one. Plus, come to this one now, length times breadth. For the length times breadth, here, this times this, the down part here now, that will give us 15. You are subtracting this and this, and then we are having the length. This length is this one. From here now, trace it here. This line here, trace it here. That becomes 30 times 15. The base, that's this minus this. So plus, I have this times the base of this one here, this minus this, that's what you do. This minus this will give us 10 times the height. The height is 30. This is the height. This is what we share here. So what then do we now do now? We start taking this one. I told you that this one will give us 15 here. So when you multiply this, we're having 75. Plus, the next thing we'll do here is 30 times 15. So here will give us 45. This one here. Plus, here, if I cancel this, I'm having 5. So doing this one, I have 150. 5 times this one is giving me 150. So the total distance, that means addition of all the 3 diagrams, will give us this plus 150 plus 75. I have it here to be 675 meters. So this is the total distance. So this is just like the distance we have just calculated. The distance we have just calculated here. So this is how this ones go. So this is just how you do it. So whenever you have to calculate total distance, is to add up all the diagram under the velocity time graph. So let's do one more on this. Let's do one more on this. Remember my distance now. What if you're asked to calculate? What if you're asked to calculate What if you're asked to calculate So what if you're asked to calculate Okay, so what if we are asked to do this? Let's say this one is included in the question. They said we should calculate the average velocity over the period. That means for this one, to calculate the velocity, velocity means here the total time, that means total time, total distance all over total time. That means we are just dealing with distance over time. That's the English here, distance over time. So what was our total distance? That means when we added this one, and added this one, what did we get there in total? We had 675 all over. What is our total time when we added this to this and then this to 10? Because 5 was added to 15 to give us this, and then 10 was added to this to give us this. So the total time here becomes 30. So that will give us, that will give us that will give us 22.5 meter per second. So this is how this is calculated going forward. Whenever you have to calculate the average velocity over the period, this is how we do it. Distance over time in total. So thank you very much. All right. So we have the number 2 questions on the board, which is this here. So let's go over it quickly. An object starts from rest and reaches a velocity of 32 meter per second after 11 seconds, comma, it maintains this velocity for another 11 seconds and then finally comes to rest with the total time of motion being this. The first question reads that we should draw the VT. VT means velocity time graph. Velocity time graph to represent these motions, and also what is the total distance covered, and also what is the acceleration one and the deceleration of these graph or these questions. Okay, first, let me just draw a little sketch here. So let's get this one drawn out here. So I have this. So this is my time and this is my velocity. So we said that an object starts from rest, that means from here, 0, and reaches a velocity of 32 in 11 seconds. So it starts from rest like this. This is where it reaches, and then reaches to this point at 32 meter per second. So here is where you put your velocity. This is where you put your velocity. Here is 32. So next up, I said at 11 seconds. So 11 seconds comes down here. This becomes 11 seconds. Then they now say it maintains this velocity. So whenever you hear maintain velocity, uniform velocity, all of this one goes like this, maintain. So I have this. So from this point, what do we know from this point? We know that this velocity, they said it maintained this velocity for another 11 seconds. So I told you that the time should be added. That means we are adding this 11 seconds to this 11 seconds. This is 11 and this is 11. So the next time here becomes 22. 22. That's the next time. That's our next time. And then finally comes to rest. To rest here means our retardation or our deceleration. That is it. It has come to rest. Now, coming to rest now, they said with the total time of the motion. So they have given us the total time of the motion to be 50. That's what they give to us. So in this case, you don't need to add again. You don't need to add it up again. This is 22, and then this becomes 50, because they said that the total time is 50, is given to be 50. So you don't need to add up anymore. You just draw the diagram and proceed to what you are calculating. So from this point now, let's start calculating. Now we have been able to do with the first diagram. This is the first diagram here. The first diagram, the first question is draw a VT graph. That's the first question. Draw a VT graph, which is what we have done already. Now, this is the graph, and this is the explanation. Next up, they said, I here, we are asked to we have to calculate the total distance. So I told you that in the other video, I said the total distance is simply the addition of this first diagram here, the second diagram here, and the third diagram. So you can either label it 1, 2, and 3, or you can label it A, B, and C as you want. It's up to you. So from this point, what do I do from this point now? I'll take these things up so that I can start solving my question. So from this point, I want to calculate the total distance. Now, for the total distance, I already told you guys that the total distance is simply the addition of the three diagrams. So I've done the first example. So let's work with that. So first, you don't need to draw. Me, I'm just the one drawing. You don't really need to draw. That is drawing the structure. But if you want, no problem. So we said that we are adding each of these. So first, I'm having the first diagram, which is a right angle triangle here, plus this rectangle here, and then plus this one here, this one here, this one. So from this point now, what do we know to do from this point is that we are going to work with the area. So the area of this, because we want to calculate the total distance now. So total distance, the area of this one now is half base times height plus here is length times breadth. This is a rectangle here. This is a rectangle plus here I'm having it as half base times height. So this is the value we just need. So what's the next thing we do now? We'll start imputing value. For the base of the first diagram, the base is just all of this one. From here to here is 11. So this becomes the base. So here becomes 11 times, what is the height? I told you the second question that this place, this diagram here, is also what we have here. Look at it here. It's also what we have here. So it's just the inversion. So if here to here is 32, it means that here to here is also 32. So I'm going to introduce 32 here. Plus, here I'm having my length and breadth. Now, the length is this one. The length for this one, this is the length. So trace the length from here, trace the length here. We are having that to be 32. How about the breadth? The breadth is simply the down part of this diagram. Subtracting this from this, 22 minus that gives me 11. So from this point, I have this times the next thing here, the base. The base is simply this minus this. And then the height is this. We are still maintaining the same height. So maintaining the same height, now we have this. So this is 8 here. And then this is 4, which will give us 28 here. Times the height. The height is 32. Please, this is the height all together. This becomes the height all together. So from this point, what do we know to do from this point here? We are now going to do some calculations, very quick and sharp. Remember, we are calculating I is the total distance. The next thing we'll calculate after I is acceleration and deceleration. So let's take that out. So from this point now, let's quickly reduce this. This becomes 16. You can either reduce any of them, you are correct. So if I reduce this one, I'm having 40. If I reduce this one, I'm having 16. Any one you like, you are correct. So I'm having this. So what then do we do now? We have to multiply 1 times 11 times this for the first diagram here. So I have 11 times 16 here. I have it as 176. Plus here, I'm having 32 times 11 here. I'm having 352 plus this one, please. So I'm having 28. 28 times 16 here, I'm having it as 448. So I'm going to sum them up because that talks about the total distance. So summing them up now, I have 352 plus 176. So my total value here is 976 meters. So this is how this is calculated. So remember, whenever you have to calculate the total distance here, the total distance talks about the addition of this first diagram, which is this, the addition of the second diagram, which is this, the addition of the third diagram, which is this. So all of this one is the total of this, or you can calculate this one separately somewhere, calculate this one separately somewhere, calculate this one separately somewhere, and then you add up all the final answer. You should definitely have 976 coming or going further. So this is the question. Now, next up now, we want to calculate I. Okay, let's quickly run that here. So I. So we are calculating two things in I. The first one there is to calculate the acceleration of the body. Acceleration of the body. So let's calculate the acceleration first. So how do we calculate the acceleration? When they talk about acceleration, they're talking about this point, please. This point where the body starts from this 0 point from rest to this point, this acceleration. So how do we do our acceleration? It's too simple and easy. So we say that our acceleration, I've given you the formula already. Acceleration is A to give us V minus U over T. Simple as that. So what is my V here? This becomes my V. Remember, this is my V. V is this one. Look at the V here. It's 32 minus, what is my O? My O is where the body starts from rest. My U, sorry, is where the body starts from rest. This is my U and this is my V. Just trace your V here is 32. Your O, trace it. Your U, trace it here is your O. So here becomes this. The total time from here to here is 11. From 0, the time read to this point will give us 11. So I have this. From here, I'm going to simply, this minus this one, I have 32 over 11. So A, therefore, will simply give us 32, 11. I have 2.90, 2.91. So I have it in meter per second square. So this is how all of these things are done. So let's put it as A. Let me put it as A. So this is the A part because the B part talks about the deceleration. So this is it. Now let's talk about the deceleration part of this question. So deceleration, I told you that deceleration simply means retardation or when the body comes to rest. Now in this diagram, the body was here first. This is where the body, when the body maintains speed here, then coming down becomes the final speed, the speed where the body comes to rest, which is V. So V here becomes 0. V here becomes 0. While U maintains this one, just trace it here like this, trace it here. So we're using the same thing. So and also note that deceleration is simply the opposite of acceleration here. So we're using the same formula where we say A becomes V minus U over T. Just know that your diagram, your answer will have 0. Acceleration is having plus. Sorry, your diagram will have minus. Acceleration is having plus here. So deceleration or retardation, this or this, they are the same thing, guys. They are the same thing. So any one of them you meet while solving this is the same thing. So next up here, how do I do this? From here, my velocity here is 0 because this is where the body came to rest here. So V here becomes 0 minus, what is my U? Just trace it here. Trace this line from here to this point. That is 32 there, all over. The T, that means this from this. Subtract the big, subtract the small from the big. That will give us 28. That's what we have there. This minus this one. That's the total time. There's 28. So what do we now do now? We now have minus 32 here divided by this. So that will give us my value to be 1.14 meter, and they maintain the same unit, meter per second square, and we have this going forward. So let's calculate the last thing. What if we are asked to calculate the total distance of the period, the total distance or the total velocity, please, of the period? What do we do? So this is the final answer for IIA and IIB. This is the B part. So this is what we have. Now let's calculate the total distance of the period. The total distance of the period. So let's take this one out. The total distance of the period, if we are asked to do that. So that will give us our this value, IV here. So let's calculate the total velocity, please. The total velocity of the period. So how do we do this? In this case, it means that since we're talking about velocity here, it means that we want to calculate total time or total distance. Let me use total distance because velocity is simply distance over time and then total time. So it's just like this. It's just like this. So it's simply distance over time. Velocity is distance over time. That's the concept. So what do I have here as my total distance? When we calculated all the diagram, this, and this, we had a quick answer there, which is given to us as 9 967. So the total distance that was given to us is 976. Sorry, 76. If I'm not mistaken. Where we added all of the value to give us 976. Yeah, that's the total distance. Now, the total time is the addition of all of this. So they said that the total motion from here to here had a total time to be 50. So total time here is 50. Just divide it and voila, we have gotten our simple answer here. So 967 divided by 50 is as simple as this. So here becomes 19.52. So velocity is meter per second. So this is how it is done. It's very simple, and it's a straightforward thing. Please also bear in mind that what we are solving are past questions. See you in the next class. Okay, welcome to number 3 question on my board. Let's quickly profile solution to this WAEC question on the board, and it's simple. So please follow the video from the beginning to this point, because if you miss anyone, you are likely not to understand what we have been doing, and it's quite simple. Simple as ABCD. A car starts from rest. Okay, let's start drawing it instantaneously so that will enable us to get a clearer picture to that. So let me just use this point as the line and then this as my time. Okay. So with all said, just note that it is imperative you understand the concept of this, because that's concept that you must follow. So if you don't follow the concept, I don't know, you might likely not get it. So a car starts from rest. So this is where the car is. The car, we assume the car to be lying, not that we are drawing the real car. And accelerate. So I told you that the moment you see the word accelerate, just take it up. Simple. Now, for 5 sec, so we are told that here is 5 seconds. Bring it down, bring it down. For it touching here, this is describing 5 seconds. So you don't need to put the S, but this is describing 5 seconds. Then until it attains a velocity of this. So that means here becomes my velocity, this one of 30. Really? From this triangle, what is the next thing we do? They say it then travels with a uniform velocity for this. So I told you that whenever you hear the word uniform velocity, it means the same thing as constant speed or uniform velocity. Constant speed or uniform velocity. That means that the body goes straight. That's the meaning. It goes straight. That's all. So it said the body maintains a velocity for this second. So I told you that you are adding the time together. So this is 5 seconds, this one, 5 seconds. So add another 5 to this 15. That gives us 20. So when this drops down here, we are having to be 20 as our seconds. Then it now said, before decelerating to rest in 10 sec. So this is brought down to this. Now, in this case, they did not tell us that the total time of deceleration is 10. So they just said in 10 seconds, meaning that you are going to add this 10 to this 20. So if you add 10 to 20, what am I going to have? I'm going to have 30. So this is all. But if they say the total time of the deceleration is 10, you don't need to add 10. Just put 10. Don't add it again. But for this one, we are not told that we are to add the total time. And we are not told that this is the total time. So we are maintaining that. So this is the concept of all that we have been saying. So they said, I sketch a graph of this motion. This is the graph. This is the graph. Next up, they said, the next one, I is using the graph above to calculate the acceleration of the 5 seconds. Acceleration of the 5 seconds. So let me remove some of these writings here that will enable us to get the clearer explanation of what we are doing. So calculate acceleration of during the first 5 seconds. So that's what we want to calculate. During the first 5 seconds, we want to calculate that. So now, solution, please. So I have A. So the acceleration during the first 5 seconds is what I want to calculate now. Acceleration during the first 5 seconds. 5 seconds. So this is it. Now, what do we do? This is what they're telling us to calculate now. This diagram. That's what they're asking us to calculate. All of this one like this. All of this one like this. It's simple. This is what they're asking us to calculate. So that means that we are calculating the diagram. That's what it means. Acceleration of the first 5 seconds. This is the first time here. We want to calculate that now. So I will just put the diagram somewhere. Remember, I said we are using the area. So what is the area of this? Okay, first, before we do that, from here to here is the 5. So I'll have it as 5. Now, from here to this point is 30. So if here to here is 30, that means here to here is also 30. So I'll put 30 here. So using the area of this, we have it as base times height. This is very simple. This is so simple. I promise you, you are going to be extremely good at solving all of these things if you follow the tips and the steps. They're very simple. So the base here is 5 here, and the height here is 30. So what do we do now? This can cancel this. So here is 15. So if I do the math, 1 times 5 times 15 gives me what? 75 meters. So this is it. This is how this is calculated. Now, B, we are told to calculate the deceleration during the last 10 seconds. Remember that here, the body decelerated down here. Also observe that from rest, U is 0 here from rest. So here becomes V. So you trace here to be V, and then here is U. Now, for this point now, before the body decelerated to rest, this becomes my U, and this part becomes my V. Remember that anything coming to rest is 0. So the body starts from rest first. Here is 0. So note that. It's very, very important to note that. So they said calculate deceleration during the last 10 seconds. So as deceleration, please. Deceleration, which is the same as retardation. So deceleration during the last 10 sec. The last 10 sec. So from this part here, I want to calculate for the last 10 seconds, I want to calculate that. So what do we know is this point. This is the point we're calculating, please. This point, this diagram still. That's what we are calculating. So there's nothing difficult there. So I will just take my diagram out, and I will have it like this here. So from this point, this one, to get the base of this, you cannot use these two numbers. So you subtract. So 30 minus this will give us 10. That's why they said during the last 10 seconds. So that's the diagram here we have gotten. So the height, look at the height. This is my U now. Trace it here. We are always using this height. This 30 is all for the height of everything. So here becomes 30. So what do we use now? We say area becomes half base times height. That's all we use here. That will give us times, what is my base here is 10. What is my height here is 30. So that this can take care of this. Here is 5. And then we have this to be 150 meters. Okay. The way we really need is, okay, is meters. Is meters. Okay, we don't need square. It's meters. So this is this. Now, after calculating this, the last thing we want to calculate is the total distance. They say total distance covered. That means calculating this one, and this one, add them together. That will give us the total distance covered. So I'm wiping this off, and I will have this, so that we'll do the last parts of this. So from this point, to calculate the total distance now, which is the C part, total distance covered, is simply the addition of all the diagrams. So the first diagram is here, first diagram plus next diagram plus next diagram. That is all. So we are using, this is distance. So please note that we are calculating distance here. So, but we are using these formulas. That's what we are using. Plus, here is length times breadth. Plus, this one is same thing. Length times breadth times height. From this part now, what do? We have this times, I already know this one already because I've calculated for the first 5 seconds, but let me just still do it. So what is my base here? The base is this 5 here. So what's the height? I told you that the height is the 30 here. Every diagram here uses the height or the length as that. So this is 30 plus, for the rectangle, the height is the length. So this is the length. Push it here. This is the base. So push this one here. This is 30 times the base is simply this minus this. This one minus this one. That will give us 15 plus half base. For this one, what's the base here? This minus this. That's the last one we have done. This minus that will give us 10 times the same height. The height is this one. I said all of them are sharing. The height is simple as A, B, C, D. So from this point now, what do we know to do from this point? If I take this one off, I'm having 15 here. Remember, we have done the first one. This is 75. So if I take this one off here, I'm having 5. You can either divide this or divide 30. Anyone is your choice. So this times this will give me 75 plus. So I'm having I'm having 30 times 15 here. I'm having it to be this value plus this is giving me 150. So you add it up. So everything becomes 675 meters. So this is how the questions are solved. Thank you and see you in the next class.